All right, so let's try another example where, again, we're factoring using the greatest common factor. So I'm going to do, how about 9 plus 15? Okay. So again, I keep the addition sign, and this time I'm going to use a different color just for, differences. So the first thing we do is find the GCF, or find the greatest common factor. Because we want to factor it, we want to divide by a number, the biggest number that we possibly can. So I'm going to start with the latter method. What is a number that divides 9 that also divides 15? 3. 3 divides 9, and 3 also divides 15. So then I do 9 divided by 3, and I get 3. I keep the addition sign in the middle, and then I do 15 divided by 3, and that is 5. Okay, 3 and 5 are both prime numbers. I can't divide anymore, no common factors. Okay, so this is going to become the stuff on the inside of the parentheses, and the right-hand side is going to help me find my GCF. So my GCF is just plain old 3. This time I didn't have to multiply because I could only pull one number out. Okay, so my new expression is 3 times the quantity, 3 plus 5. And it's equivalent to my original quantity, the stuff in black, the 9 plus 15. So again, if I were to solve the stuff on the left-hand side, it's going to be equal to, or equivalent to the stuff on the right-hand side. Okay? So this is my factored version. Factored. Okay? Now you might be asking, why on earth would I factor something if it's just as good with 9 plus 15? Well, that's a great point. One of the reasons why you might factor something is to combine like terms. It's easier sometimes if you can factor a number out, especially later on when we get into like higher levels of algebra, and you have different terms all over the place. If you factor, it sometimes makes it easier to simplify. So the whole point is just to make it look nicer, or to simplify, or to help us out later on. Yeah. So let's try some with variables this time. All right, so just as a reminder, an algebraic expression is an expression with numbers, variables, and operations. So the key here is that algebraic expressions have variables. So like 3x plus 17, or 22y minus 16x, okay, whatever. All right, so when we're factoring algebraic expressions, it's the same general idea. So let's start with 3x plus 42. Why not? Okay, so we're going to factor this one the same way that we factored the other one. We're just going to pretend, we're going to remember that there's a multiplication sign here. So that means we've got 3 as a whole number and 42 over here. So when you factor algebraic expressions, don't worry about the variable yet, because it's multiplied through. So we can just deal with the coefficient and the constant. So 3 and 42. What are some common factors of 3 and 42? Well, the only common factor I can think of, because 3 is a prime number, is the number 3. Okay, and then I can divide. 3x divided by 3 is just going to be 1x, because 3 divided by 3 is 1, and there's an x there still. I keep the addition sign. 42 divided by 3 is going to be, I am not quite sure, so I'm going to divide. 42 divided by 3. 3 goes into 4 one time. That's a 3. And then 3 goes into 12 4 times. So the answer is 14. Okay. Since 1 is a prime number and 14 is divisible by 7 and 2, there are no more common factors we can pull out. So our GCF is 3. So we keep 3 on the outside. And then we have these two as the terms on the inside of the expression. 1x plus 14, which is going to be the same as this original expression, 3x plus 42. Okay. Please make sure that right now you write any questions that you have, Q's I have, okay, so that we can address them today or tomorrow.